Alright, hello my wonderful students. This is part 3 of foldable number 3. So for this one here we have a quadratic, and if you notice here we actually have a parentheses squared that fits the same format that we're using for the vertex form, but now it actually has a squared with parentheses instead of absolute value to suit the quadratic. Alright, so we're going to go ahead and go through the steps again. So we're going to go to our step 1. And our step 1 is identify the vertex. Alright, so the vertex is, and we're going to go ahead and check it out now. So we have here, we can move 1, 2, 3, 4 negative, and 1, 2, 3 down to hit this point here. So with negative 3 again. And remember, this is actually also our axis of symmetry that divides the graph in two. Okay, so we have 1, 2, 3, 4, negative 4, 1, 2, 3 down, negative 3 for our y or our k. Okay, so now we can go ahead and write that our vertex is, open parentheses, negative 4, and negative 3. That means our k is equal to negative 3 and our h is equal to negative 4. So now we go to step 2. So step 2 is identify the slope of the right side. Wow. But then you say, Mr. Payan, this is a quadratic. There is no slope here. It's exponential. And I'm going to be like, yes, I understand that, because it is true. But what we're going to do is we're going to find the next point that hits, or the next part of the quadratic that hits a point, and we're going to take the slope of this, even though it's not a line, to find what our a is going to be here. So we're still going to use rise over run. M is equal to rise over run. And then we're going to go ahead and work it out. Okay, so if we hear this is, our rise is negative 2 over our run of, so 1, 2, and then our run is positive 1. So our slope is going to be negative 2. This only works with the first point available. You cannot do it with the one over here, because then the slope will be very, it's just not going to work, because it's going to be too skewed and it won't work. You have to use the first point available, which is here. For the vertex, like we did up here, it doesn't really matter because it's a straight line. So the slope's going to be constant within all of it. But for this example, when we have a quadratic, you have to use the first point that the actual function hits on the right side. Okay, so now we know our a is negative 2. So our step 3, let's do it this side. Step 3 is to write the equation or function. Alright, so we have our y is equal to our a, which is negative 2. Then we have our open parentheses x minus h. Our h is negative 4, so minus a negative 4 makes a positive 4 squared, plus k. So since k is negative, we're actually going to have minus 3. So if we look at this here, we can see that since this is negative, it's going to be going downwards, which is good. We have that our parent function shifted 4 to the right, 1, 2, 3, 4, and then it shifted 3 down, 1, 2, 3. So we know it's here downwards, and we know that the next point is going to be at 2, 1 instead of 1, 1 from it, because of the slope that we got, or the a, which is going to be stretching the graph down.